on that similar intuition about how do we take very contextual ways of doing archival practice and operationalize them and make them legible to machines. So let me remember where the slideshow button is and we'll be in business. Frederic and I are here to present, but we are part of a very large, wonderful team, and the bolden names are the members of the group who authored this paper: Michel BARBEAU, Mario Beauchamp, Erin Gilmore, me, Iori KHUHRO, Nick RIVARD, Frederic, and then Jim. And it's my real pleasure to be able to present this work. This is very much a collaborative effort. And so people are always like, another privacy paper. Yes, always privacy papers, because privacy is very polysemous and it's come to kind of represent, I would argue, a whole lot of different values and actions that we see as important vis-a-vis kind of an ever-encroaching surveillance state. And privacy has become a real problem for archivists because the privacy mentality seems at first glance to not be very simpatico with the way we do things, because our goal as archivists ultimately is to provide resource or provide access to records, whereas privacy is arguably about protecting records. And so how do we manage that to balance that, to thread that needle? And so in this particular project, the problem we're confronted with, which is one I think pretty much all archives are confronted with at this point, is that we now have more records than any human could ever even hope to lay eyes on, literal kilometers, miles of records. We have more privacy risks than ever as GDPR and other data privacy regulations expand. And so where does that leave us? There's been a lot of really awesome work out there that's dealing with privacy. For example, Vicky's project making archival data available archival records available as data in a privacy protecting manner. But sometimes we need to be able to use records qua records. And so how do we do that in the context of these ever growing privacy regulations? Part of the problem is that privacy, like I said, is polysemous, which means it has lots of different meanings in it. And it's also very context dependent, just like what we do in archives is context dependent. So contextual integrity is a theory of privacy, which argues that it is the context that determines whether a particular sharing of information is or is not a violation of social norms. We have some contexts or some ideas of social context in archives as well. And in particular, one of the intuitions that really got this project going was the argument from Helen Niesenbaum, who wrote the original Contextual Integrity book, that we need to be able to identify things like senders, receivers, aims, norms, etc. when it comes to identifying whether or not something is a privacy violation. To which I said, I know people who can do exactly those things. We call them archivists, and they do it through a thing called diplomatics. And so our goal here was to use archival diplomatics and contextual integrity as an intellectual framework to develop a means by which we could make the context of records, and in particular the social privacy context of records, legible to an AI system to help support an archivist in the loop sort of system for identifying potential privacy risks within a given corpus. And so we had kind of these two questions, which is, can we use these theories? And if we can use these theories, can we then use them to develop automated tools? In particular, automated tools that work in the kind of low resource, lone arranger perhaps type of environments, and to minimize risk while maximizing return. That's all. Oh, and I hit a button. Sorry. And so we started by going through kind of the different contextual questions out there, looking at privacy laws, looking at contextual integrity and other theories, and then archival contextual questions. So archivists, of course, will be familiar with all of these things. They exist in every descriptive standard that has ever existed. And in the privacy world, of course, we're looking at things like aim, what's the goal of sending this information? How are we sending it? Do we need consent? And all of that. And then we combine them into a framework here. Whereas you can see we have these primary elements of contextual integrity, and you can see some of these things come from what's called the GKC-CI, and these are developments of the original contextual integrity framework that Nissenbaum developed, because contextual integrity remains an active area of privacy research. And we started mapping these to be able to train to be able to develop an ontology through a knowledge graph that would make the context of records, and particularly the privacy concerns of that context, more legible to an AI system. And in particular, we wanted to use both vector and knowledge graphs. And the reason for that is that LLMs understand numbers, not words. And so the typical approach uses what's called vector representations. So you turn, apple, banana, monkey, lion, elephant into numbers. And the numbers for those words are closer or further away based on how similar or dissimilar they are semantically speaking. So apple, banana, orange all are close together because they're fruits. Monkey, elephant, bird are close together because they're animals. But there's lots of relationships that are not immediately obvious to this kind of representation that are nonetheless important. So as humans, with our particular cultural context, we would say, oh, there's a relationship between monkey and banana because monkeys like bananas, right? Similarly, when we start trying to look at the relationships in a corpus for their particular privacy risks, we need to be able to show not just the semantic similarities between things within that corpus, but also the relationships informing it. And so ontologies and then knowledge graphs allow us to show those kinds of relationships. One thing that makes us different from Tiago's work is that building the kinds of ontologies we would need is just too much, especially for a low resource environment, to do by hand. And so we use an LLMs to build it. And in particularly, we chose to use what's called GraphRag, or Graph Retrieval Augmented Generation. And I will now hand it over to Frederic.
Thank you, Darra. So as Darra said, we want to use GraphRag because we want to use a knowledge graph to represent the information. So our goal is to use an LLM to answer questions about a large corpus. We want to represent that corpus in a way that the LLM can understand it. So the traditional way to do that would have been what is done in a RAG process, or the retrieval augmented generation process, would have been to use a vector representation. So to convert all the words and all the part of the text into vectors or sequence of numbers. And like Darra showed, this is not always adequate because it does not capture all the relationships between entities that form the context and that we actually want to use. So that's why we want to use a knowledge graph. And as a simple example of the knowledge graph, if there you can move to the next slide. Here we can see a knowledge graph that represents, it's a very simple knowledge graph that represents the relationships between Steve Jobs and the company Apple. So we see that Steve Jobs was born in San Francisco, founded Apple, and so we see all those relationships that cannot just be captured by a vector representation, because Steve Jobs is not semantically related to San Francisco. 2007 is not related semantically to iPhone, but they are related in different ways. And these are the information that can be captured, that can be detected by the LLM. That we hope will be detected by an LLM, and that we can then use in our context. Next slide, please. So our GraphRag process has multiple parts, has two main parts. So once the knowledge graph is built, so of course is the first process of building a knowledge graph with the LLM. The user would input queries, then those what we call the retrievers, so basically tools and software that will look for information related to the queries. These will actually look for information inside the knowledge graph. And there's actually multiple retrievers that we can use. So and each will correspond to an LLM, so we can instantiate as basically as many as we want. We still use vector search. So so we still are able to represent documents as vectors, like in a traditional RAG process. But we also, on top of that, use graph retrievers. So we can really combine both approaches to get more accurate results. And so those graph retrievers actually use the structure of the graph. So to find, for example, in the previous graph, that Steve Jobs is related to Apple. Once all of those, so once each retriever does its job and finds information related to the query, it sends it to, it formulates a partial answer. And as we will see on the next slide, because we have multiple LLMs acting together, Darra, if you could move to the next slide. Yes, this one. So as we can see, because we have multiple LLMs working together, that each form like partial answers, we use another LLM that we call the master LLM to sort of collate or combine all those answers together into a file. And one advantage of that is that it allows us to really play around and test different capabilities of different LLMs. So, for example, we can try different retrievers. As I said, we have a vector one and a graph one, but there can exist others in the that are implemented. We can also test different capacities of different LLMs. So some are better for maybe some have different functionalities. Some are good in different languages. Some have reasoning, and so on. And as we can see on the next slide, so here we can see sort of like a schema of the general process. So first we input the files into an LLM to build a knowledge graph that is hosted on, here we use Neo4j, which is this graph database company. So this is where the graph is hosted. This allows either to use, this can be hosted either locally or on the cloud. And this knowledge graph is then used when we perform the graph write process. So when a user inputs a query, the query, the question as well as the conversation history is fed into an LLM. The fact that we also use the conversation history also helps with the LLM with answer in a longer conversation. For example, like you might ask, in a previous question, you might refer to, that person that sent the email to that other person, and like maybe you give out names in that question, but then later you ask another question about referring to those people to the LLM, and so the LLM will first rephrase that question by retrieving these previous parts of information. Then the rephrased question, along with all the context from the knowledge graph, will be sent to multiple LLMs. So here we're illustrating like Llama 3.3 and Quen 3.14. So these are just names for open source and freely available LLMs that you can find online. And so these are just two they're state of the art. They provide very good results, but and they're two out of a very wide collection of LLMs that we can use. So like we actually use multiple ones in our process, and the only limitation is basically the resource we want to put in. So so if we use too many, or if we use too big, some that are too big, then it can really take a longer amount of time to answer the question. But these are very the limitations are just the resources. So, and so these LLMs will retrieve information related to the question and then formulate an answer each. And finally, those answers will be mapped back to another LLM. Here again, this is at the bottom right. We labeled it Llama 3.3, but then again, this could be any other LLM that we have available. It's just that we tested these and they give out good answers. They're actually pretty accurate.
Thank you, Frederic. So, as our reviewers pointed out, yes, we don't really have full test results yet. This is very exploratory, but we're finding this is an approach that shows some promise. So the theoretical work is pretty novel, and it's what we're seeing so far is that especially when you do the work to train an LLM on provenance. And one of our next steps now is that we're working on building out an ontology to inform a knowledge graph on the various descriptive standards vis-a-vis privacy issues. But once you kind of train the LLM to think like an archivist, it can't replace an archivist, but it can cut down the work required for the archivist to identify those records that need special attention from a privacy perspective. And as I mentioned up front, our goal is for this to be a very low risk, low resource approach because most archives are not running state-of-the-art AI labs, as wonderful as that would be. And so, as I said, this is exploratory work. The configuration modeled, I will admit I'm very conservative on privacy, would probably require on-prem deployment to make sure that we're not uploading records that haven't been appropriately redacted and protected to the cloud. We've only tested 3 of our concepts so far, and our test corpus thus far has been fairly small in raw emails primarily, but we're excited to see where the work is going. And so thank you. Please feel free to email me if it's a technical question. Frederic has volunteered to fall on that sword, and we are really excited to hear your questions and